client side. Because this talk is recorded, I officially can't say who that client is, but I get to test a mapping application. Yep. And I only just started that job in January. So please put your hand up if you test in your role. Cool. It's actually a trick question. You should all put your hands up. If you don't test, I'd be really concerned about the applications you build. Because even the act of compiling can be seen as running a test. Either it passes or fails. If it fails, you have to debug, and there you go. You just ran a test. So by actively developing software, you are constantly testing your work as well. So this is a presentation on a robot I built at a hackathon in my last company. Let's see if this works. So the name of the robot is Tappy McTapface. It was a competition, and that was the name that won. So I'm actually going to start the presentation with a demo and then go into more details after that point. And let's hope the demo gods smile nicely. I got some sound. I've lost some sound. I will have to close the app and restart. So I had some demo issues coming here today. First of all, this robot, when I developed this robot, I was a tester on an iOS team. So this robot is hard-coded for an iPhone screen. At the moment, this is not an iPhone, it's a Pixel. Similar enough screen size that this might work. And my sound is not working. Why is that not working? There we go. Sound. Now let's see. Oh, far out. Just lock the screen on me. And it did it again. Okay, oops, let's escape out of that. So I need to run a node server on my local machine. Can you see that? I might make that a little bit larger. Oops. Now, just pretend that there is a phone running underneath that one, and we can play some script like this one, and it was supposed to play Jingle Bells. I'll see if I can get that to work. What I will do is I might pop this one up, so you might be able to see that one. Was it still running? Let's see. No, still. Can't see my password. I'm obfuscating that one. Is that the word? Yes. And then on top of these phone problems, I actually grabbed my work laptop instead of my personal one, I didn't actually have Node installed or my source code. Good thing that was all on GitHub. Now let's see if that works again. Oh, there we go. There we go. Back to the presentation. There we go. Demo. The demo gods finally got there. Now, so this is based. Actually, I won't move away from the microphone. I just realised. No, it's okay. I've got something in my hand, so it's having two things gets a bit hard to coordinate. This is based on open source repository by Tapster. The design I followed is Tapster 2.0. You can download all of the 3D printable files, the source code, some examples following that link. Created by Jason Huggins, which is I'm not too sure if that's how I should pronounce his name. Huggins, I don't know. But he was the creator of the Selenium framework. So he just wanted to, I guess, expand the automation in web to try and expand that to be automation in mobile as well. And you can see there that there's an earlier prototype of the Tapster bot, and it's trying to play Angry Birds. All of the green parts and the yellow parts, most of the parts are 3D printable, except for the other bits of hardware, most of the frame. It took me about 20 hours to print most of the parts. As an example though, note to self, do not put prints near the end of the printer. You might stuff up a little bit. So my first print didn't work all that well, but I got there in the end. The larger parts were laser cut. I went to Hackerspace in Meadowbank, Robots and Dinosaurs. If you've ever been there, it's a pretty cool space. I've been meaning to check it out again, but there's a free plug. And they had someone there help me laser cut the sides, the base, the top, and the other stuff that I wasn't able to print myself. It uses an Arduino on as the controller, and there are 3 servo motors attached to the Arduino. It uses magnets and ball bearings for joints, so I can actually just take these things off and I'll pass them around. And you can take the magnets off the joints or the ball bearings off the magnets. It took me about 2 days to build. So this is my first serious Arduino project. I was surprised at how quickly it came together. I was expecting it to take a lot longer. But once everything had arrived and the parts had been printed, the actual build time wasn't too hard. I spent a day in the hackerspace assembling it and maybe 2 afternoons after work. And I felt like the learning curve wasn't too hard. I think my previous Arduino experience has been purchase a starter kit, get an LED light to switch on and off, and then go, well, what next? So I came at this from a fairly introductory level to Arduino. I have done robotics previously, but more around Lego Mindstorms, teaching kids how to program, and fairly, so a slightly different tact. So I don't come from a huge Arduino background, and I found this not too hard to pick up. It cost me about $300 in parts, and I think it was because I got them imported mostly from the States, because I was following an American recipe in how to build this. A lot of the parts were in non-metric measurements, and I didn't want to go with a local supplier for some of the parts. Now that I've built it once, I know what I'd be looking for, and I think if I went for local suppliers, I could probably get that a little bit cheaper. So I think the postage really impacted the cost there. And we hacked that Play Piano JavaScript class in a 1.5-day hackathon. So this was a hackathon for Tyro, my previous company. This was just before Christmas, so hence the Christmas carols and the Christmas theme. It runs a standard Fermata protocol on the Arduino board. Don't really ask me how this works. I think it's just magic, but the standard Fermata protocol allows you to have your code, your JavaScript code, running from a node server on your local machine, and it translates it across to machine code somehow. I just installed Fermata and then went node play, and it worked. So it wasn't too hard to get that up and running. There's also another electronics kit that you can use that runs JavaScript natively. I can't quite remember the name of it, but it's in between Arduino and Raspberry Pi in terms of functionality. Runs a Node JavaScript server locally. Uses the Johnny 5 JavaScript API, which is an Internet of Things platform. It's reasonably new, it's only a couple of years old. If you have developed for JavaScript before, there might be some things you might not be able to get for free. The Johnny 5 library itself is fairly limiting. If you're used to doing things a particular way or using a particular library, this might introduce some challenges, but it has a lot of functionality out of the box. We've mapped each key to XYZ coordinates, so there is already a function included in the source code that converts the rotations of the motors into XYZ coordinates. If you remember anything from maths, that's converting rotation coordinates to a Cartesian coordinate system. I think it's the first time I've used that type of maths since high school, and I'm glad someone else did it all for me. All those thetas and sines and cosines and whatnot. But so we've at the moment, this is just hard-coded to certain XYZ coordinates on a screen. We move to maybe a pressed or a lifted position above the phone, because if we moved from pressed to pressed, we get this curve motion and we might interact with the screen. Like you saw with the demo, when it was moving from one end of the keyboard to the other, even though we were telling it to move in a straight line, that caused the rotation to curve and accidentally touched the screen. Because this phone's a little bit thicker than an iOS, I would need to raise the lift up a little bit higher so that when I was moving quickly, I wasn't accidentally touching the screen. But, you know, that's for next iterations. And then we've just mapped a string for each key. And then we write music in a string. So there was you can't see Jingle Bells there, but Mary Had a Little Lamb. We just have one letter to represent the note pressed. The double E right at the top says to press it for twice as long as everything else. And the 4 C's at the end says press it for 4 notes. So that was our first attempt at translating music across to the machine. We got more advanced. Required a slightly larger keyboard, and so the keys were more densely packed, and I would have demoed those ones on my iPhone, but I didn't trust it on the Pixel. But there we've used numbers to represent how long to play the notes for based on 1/16 of a bar. I'm not sure if you come from music backgrounds, but generally, I guess with most music, it's based on 4/4 timing. There's 4 notes per bar, and we've broken the smallest note we had in some of this music was a semiquaver, and there's 16 semiquavers in a bar. So, but playing a note for that short really impacted the timing as well, because one quick note was actually proportionally larger because of all the movement in between than a full note. But so tweaking the timing a little bit. It's not perfect, but it was part of a hackathon. And how can this help you test? I think it has fairly limited functionality at the moment. I think a lot of the UI frameworks are already quite mature, and they're probably easier to use than, say, dedicated hardware. When you have hardware on top of software, you introduce another variable where stuff can go wrong. We already saw with the demo that it was hitting keys that it wasn't meant to hit, and the robot itself didn't know that it was hitting wrong keys. So that introduces an extra level of debugging. But being able to debug this in JavaScript is amazing. I've never been able to debug hardware and robotics that easily, and I quite enjoyed that part. I think if you wanted to set up some sort of performance testing or on a real device or load testing over time, say you wanted to see how your app, like active app use, fared over 4 hours of battery usage, you could set this up with your app, let it interact a little bit over and over and over again, and monitor your battery usage. I think that's probably one of the more applicable applications of this robot, because sitting there and doing that for 4 hours would be quite tedious. You could also, I guess, use it to automate your Snapchats. Apparently, Snapchat doesn't allow you to schedule chats, but a robot could. You just tell it to go off at 2 a.m. Does anyone else have any other ideas of how they could use this robot?
Maybe you can just clean the touch screen surface.
Oh, touch surface cleaner. So I think current applications at the moment are limiting, but playing around with robots is cool. And I just wanted to see if I could build it. Build a robot based on open source designs and open source hardware, and I just had so much fun doing this. My lessons learned from doing this. The instructions to build Tapster 2.0 were hard to find. They weren't included in the GitHub source repository. There was a makerspace online DIY website that had instructions, but the parts were a little different to the actual build of materials from the GitHub repository. So that meant I printed too many parts, or I ordered not enough. I had to go back to using metric nuts and bolts because the instructions I was following had different amounts of screws than the source code, unfortunately. But hey, I learned that one. I would commit back to the central repository with an updated build of materials and instructions, or at least maybe a recipe for trying to build it in Australia, but I haven't developed it or thought about, you know, it takes time. Who's got time for that? I got work to do. And that's about it. Questions?
Time for a few questions.
Yeah, I'm fine. Thank you. Is there any chance, because I remember you from the PTG.
Oh, yeah. Oh, yeah.
Yeah, awesome. But is there any chance that they will do the multi-touch function, or just do the press?
I think multi-touch would be quite challenging. At the moment, there is limited space with this one, so it would be possible, but you'd have to go through the whole process of designing your own robot to do that. I guess it's possible you could have 2 sets of servo motors pointing in, but you probably would have to design them to be a bit smaller so that they could both fit in the same space. It's possible, but it would require a new design. OCR. Yeah. I think in terms of, the robot being a bit smarter with where it's pressing, I actually think OCR might be over-engineering image processing. But I think if you had an app in debug mode plugged in via USB, at least on the iOS space, you can read the UI elements based on that and then have something running locally to convert that back to XYZ coordinates and then send the command to the robot to press that button. So that would be my first step, is to try and build something that could take in the XYZ coordinates of UI elements based off running the app in debug mode and then sending them back, which would require a bit of calibration and tweaking, or we could get a lot smarter with calibrating this for different screen sizes as well. There's a progression, like if you were able to detect force, you could detect the edges of the screen and map out the screen size. It might take 5 or 10 minutes to calibrate, but you might only have to do that once. Yeah.
Are you capable of doing 3D touch?
3D touch for iOS 10? I can't see why not. It does work off capacitance, and it'd be worth testing out. But it's a good question. I think it depends on how the 3D touch works. And if 3D touch works with styluses, then this should work, because this is just using a stylus.
On 3D touch, I would imagine that you need a way of sensing the force that you're pressing.
Yeah, which generally most servo motors which you should be able to read the amount of force pushback generally from most of the motors. Depends on how much you want to spend.
Cool. Thanks, Sam.
Yeah, you could do it with a Raspberry Pi. I just found the Arduino to be easier and more approachable, also cheaper. But there's also an in-between circuit that can run JavaScript natively too.
Sorry, we good? Thank you, Sam.
Cool.